So I answered a lot of questions on Reddit about, should I take Math 114? And I always tell them that you don't really need to know anything for Math 104 except like, integration by parts. But one thing that is really crucial about taking Math 114 then, and I might have mentioned this in the intro video that I'm going to make for the Plug and Chug series. Haven't done that yet. I do it at the end. But you want to be very comfortable with your algebra and you want to be able to recognize, squares. You want to be able to, perform calculations quickly, including integrals and derivatives. And arc length really is the first time that we'll really get to see this. So this is where the integral first rears its ugly head, I'm pretty sure. And it's going to be a big part of the rest of the semester is integrating stuff. So again, if you're watching this video towards the beginning of the semester, it doesn't hurt to go and just Google like integration problems online and just do some integrals. You're gonna need to get good at integrating quickly. Like time crunch is a real thing. Arc length, really simple problem. What is it? Well, if I have a curve in space and I want to find, right, so let's say this is some curve r of t, right, and I want to find the arc length of this segment right here, let's say, from t equals a to t equals b, right? So a is some initial time and b is some ending time that I'm traveling along the curve. Then the arc length is equal to the integral from a to b of the magnitude of the velocity vector, so the magnitude of r prime of t, right, dt. Okay? And let's explore then this problem from fall 2008, number 2, which is the following problem. R of t is 2t 4/3 t to the 3 halves, 1/2 t squared, and you want to find the arc length when t is from 0 to 2. Okay? And so, well, given that formula, it looks like we need to find the derivative, and then we need to find the magnitude of the derivative. So r prime of t, which is the velocity vector, is going to be equal to, and these guys really should be vectors, right? This is equal to 2, bring down the 3 halves, and that becomes 2t, and then this becomes 1/2, and then this becomes, bring down the 2t, okay, by itself. All right, so that's what r prime of t is. What's the magnitude of r prime of t? Well, that's equal to 2 squared plus 2t to the 1/2 squared plus t squared, right? And that's equal to 4 plus, okay, and then you can just essentially raise each guy here to second power. So that's 4t plus t squared, right? And remember, when you raise t to the 1/2 squared, you multiply that guy in. If you have t to the 1/2 times t to the 1/2, however, that's just equal to, well, that's also equal to t, right? T to the 1/2 times t to the 1/2. This is t to the 1/2 squared, and so you add these exponents. Or, in this case, when you're raising an exponent to an exponent, you multiply exponents. So, again, just clarifying an exponent rule. You guys should know this already. I'm just being pedantic. And so, all right, so this is 4 plus 4t plus t squared, and this is where you need to recognize, hey, wait a second, this guy under the square root is actually just 2 plus t squared, okay? And so that means the velocity vector, or the magnitude of the velocity, is really 2 plus t, okay? And again, the magnitude of velocity is speed, but I'm going to avoid using the word speed, and so we're just going to call it the magnitude of velocity. Okay, so that's what we're going to integrate. So then we're going to integrate from 0 to 2, right? T from 0 to 2 of our magnitude of our velocity, which is 2 plus t, and that's going to be equal to then, and of course there's a dt, which is needed, and that's equal to, right, 2t plus t squared over 2, and all of this gets evaluated from 0 to 2, and so I get 4 plus 2 minus 0, which gets me 6. All right, so the arc length is 6 units. We don't have a unit, so the arc length is just going to be 6, and that's how you do an arc length problem. Very simple. And what's the hardest part of all this? Because this looks like a very simple exercise in integration. The hardest part is really finding what r prime of t is. And on exams, it always should work out to something kind of nice. You're almost never going to be left with the square root sign here. You're always going to be able to cancel something out or bring something out and get something. And this integral right here shouldn't be a disaster. So on exams or on homework, if this integral is an absolute disaster, where like where like at worst case you're going to need a u sub it, but even if a u sub doesn't seem to work, you're doing something wrong in this step right here. And if you're doing something wrong in this step right here, it's either your algebra or you took some derivative wrong up top. So that's how you diagnose when these arc length problems are going wrong. They shouldn't be too hard. They're very simple. They shouldn't be too hard at all. And in fact, they should be like 3 points on an exam. So that's this. What's next? 13.4. 13.4 and 13.5, probably my two least favorite chapters in this book, but we'll get through them. Just a bunch of derivatives coming your way.